basically where that all came from. Whoops. So I had a little note here on names. I guess that didn't make it. I guess for some reason that slide. But we have Steve Garcino from Quantum, which is presenting. He's the senior system architect for the group. Phil Bennett is the vice president of engineering technology for Abacus. So first up is going to be Steve. And Steve, here you go. And your arrow is right there. Thank you so much.
Oh, cool. There we go. First off, I want to thank everybody for inviting me here to be here this evening. And I do like this. This is a full room. I was asked by Doug Cole of LH Computing to come down and speak to the group tonight. And now listening to Ken's intro, I live in the Washington, D.C. area. I would much rather come down for that December meeting than the July meeting in Florida. It was the exact same temperature when I left home yesterday that it was when I got here. So for future reference, anytime you can get me down here December, January, I would be more than happy to show up. What I wanted to talk about today, actually the discussion was suggested to me, the title, is media workflow and ending out at the cloud. Anytime you turn on television now, there's a commercial for the Microsoft cloud, for somebody else's cloud. Every time somebody's boss goes to a conference, all he hears or she hears is cloud. Everything is going to be in the cloud now. But then when people stop think about, what is the cloud, they've been using the cloud for years in various different things. Your ISPs have all your email out in the cloud, et cetera, et cetera. It's just a matter of now developing a cloud for your content. And we'll get to that a little bit later. But I did want to take a moment, if you're not familiar with Quantum, just to tell you about our company. This isn't supposed to be salesy, just to kind of give you some background as to, I can hear myself, as to who we are and what we do. Quantum has been around for 35 years. We just actually had our 35th anniversary a couple months ago, and our CFO was invited to ring the bell on the New York Stock Exchange that day. So that was pretty significant for us. Most people, when they think of Quantum, excuse me, Phil, can you hand me my water bottle, please? Sorry about that. Most people think of Quantum, you're the guys that make the disk drives. And Quantum did do that 35 years ago and for a number of years. The way to think of us as the tape library people. And we did have tape technology. Quantum is one of the 3 members of the LTO consortium. So our organization helps to make the rules for the next version of LTO and where tape is going to go. So, and I think last year I can't remember how many years in a row, we finished as the #1 tape vendor in the world. Tape library vendor, I should say. 1,600 person organization. We're a significant company. We've been around for quite a while, but in recent years, we've transitioned from being that disk and tape company to be more a generic storage company. And a lot of our focus has turned to the media and entertainment world. We are best known now for our StoreNext file system. Golf Channel uses it. I'm sure there are a number of other users in the room here, which is basically the fastest high-speed shared file system technology available out there, bar none. It's become somewhat of an industry standard. We're used by all the TV networks, the major studios, most of the major cable networks, et cetera. So just a little bit of background on the company. I've been with Quantum about 3.5 years, working a couple of years up in New York, and now I've moved down here into the Southeast. I much more enjoy coming down. I'm not sure where you're from, Ken. It doesn't sound like from around here, so if I insult New York.
Like the car in the yard.
Yeah. Let's just say I enjoy working in the Southeast a little bit more than the Northeast. My wife is from Brooklyn, so I can't say too many bad things about it. Somebody from Brooklyn in the room. Anyhow, get beyond that, but I do enjoy coming down here and working in the Southeast. Got a lot of customers. Actually worked with Brian and Ken at my previous employer here with some work at the Golf Channel as well. Or, I'm sorry, at Golf Channel as well. No more the. Okay, this is going to focus more on workflows in the media and entertainment space, different types of workflows, challenges that we've encountered over the years, and then the additions that have been made to the technology that have affected how the workflows are supported, managed, et cetera. This is your basic start on the left, end up on the right type of thing that all of you are familiar with. it's, all those steps are in there for everyone, depending on what your business needs are, whether you're the content creator, the content recipient, the content provider, distributor, what have you. Different components of this workflow come into play, but as it says at the bottom, workflow is more than just data moving around. There are a lot of components in it, a lot of things that you have to consider, and those are the things that we specialize in at Quantum, is helping our customers with their workflow. We don't walk in and say, if you want to use our stuff, this is how your workflow has to progress. We walk in, we talk to you, we find out what it is, what your business needs are, what your workflow has to be, and we build a system underneath it to support that. Adding in the components to augment what you might already have, or building it from scratch, depending on what the situation is. And amongst or below all of these workflow components is the storage environment, the data management layer. And it really becomes a matter of matching the different components of the data management layer to the workflow components of the environment that you're working in. There we go. So just your standard production workflow, this is very generic. In the high-res world, you ingest your content on the upper left-hand corner. You may or may not have an asset manager involved. Content goes into the work in process. Your editors do their artistic magic. They create the content that's going to go out to the world. At some point, it may have to be transcoded into a bunch of different formats depending on how it's being delivered. I used to work with a cable network up in New York that had to deliver everything in at least 16 formats, and most of their content in even more formats than that. So transcoding was a huge bit for them, and building the environment to support that was important for them. At some point, the content is no longer work in progress. It's going to go to another storage tier, and we'll get into that a little bit more. We call it extended online if it's content that's being not archived off, but moved to a lower, lesser performing tier for faster availability, less latency. But it's a disk-based tier, but not spinning or not RAID-based storage, not just another copy on RAID, the expense of that. And then you got to deliver it. You got to, again, convert it to new formats, deliver it using the various different tools that are available. And you also have to preserve it over time, put it out to an archive, and up till recent time, the standard archive for pretty much everybody was tape. Which, when you're primarily a tape vendor, was a very good thing for Quantum. But now people are moving off of tape and onto new alternatives out there. You know, we have to deal with those as well. But the key to it is that in and amongst all those arrows is a bunch of hardware, and that hardware has to be built and configured in such a way that it'll support that workflow. So you've got a workflow, content comes in one end, goes out the other, and it's got to sit somewhere and move around within that environment in between. And that's really where Quantum has made some changes in recent years to handle that. So going back to a portion of that previous slide with the data management layer, you got a lot of things to take into consideration on your primary storage tier. What is the requirement for that tier? You know, what kind of throughput do you need? Do I have 3 editors that are editing single stream? You know, can I support that with a NAS environment, or do I need to go to a fiber-based SAN environment to generate or to accommodate the throughput that's required to support all the speed? And that's a calculation that has to be made. Do I have transcoders that are transcoding right off that primary storage tier? How many of those do I have? I've got a cable company up in, I'm not supposed to say their name, well, actually I can say their name. They've been a reference for us, but we do it on an ask basis. But in any event, they have 14 transcoders running off of one StorNext file system, and they're going to double that number. So we have to walk back with them, do all the calculations on what kind of throughput they can generate off of that system, and make sure that we can support what they're doing. Their workflow is not changing, but the capacity required in their workflow is changing dramatically. So not only do you have to be able to support the content as it moves through that workflow, you have to be able to support the changes that happen within it. And then the secondary tier, that's some years ago, that was almost always tape. In more recent times, people have been trying to keep more of their content on disk just to reduce the latency, bringing content back from that secondary storage tier. You've got work in progress that's occupying high-speed, expensive storage media. If it's not going to be treated in the same manner, why not move it off to a less expensive tier? And there are a number of a number of options in that tier as well. You can put it on RAID. Now object storage is becoming much more popular as a second tier. Or again, you can use tape as a second tier. I've got customers that are doing all 3 things. They're just Some are making a second copy on RAID because they can afford it. They've got rack space. They've got all the other environmental requirements that come with it. Some can just use tape. That cable channel I was just talking about that has all the transcoders had 4 petabytes on tape. They were able to get their content back from tape in a manner that was supporting of their workflow requirements. A couple of years ago, that was no longer viable for them, so they've replaced that tape environment with an object storage tier. So the content is on expensive, lesser performing disk, but there is virtually no latency in bringing it back into the active file system if they need to get at it. So you consider a number of options for that secondary tier as well. And then finally, the archive tier, you do have to preserve your content. There are always a lot of different considerations on preservation, depending on the industry you're in. Some are statutory preservation requirements. You've got corporate policies that say I've got to keep this, and then other people want to see if they can monetize that content at some point in the future. So they want to retain all of their content, whether it's raw footage or it's finished products that have gone out to air. All of that content needs to be preserved, and there are a number of options in terms of that. Again, tape has been the industry standard for a number of years. Object storage on-site is becoming more and more popular. We're actually doing quite a large business in our object storage area currently. It's growing exponentially the last 2 years. And then how am I going to preserve it? Am I just going to keep it all on-site, or do I want to send it off-site? Maybe both. I keep tape on. I write 2 tapes. One stays in the library. One goes off to Iron Mountain or some other provider. Or I can have an object storage configuration that allows me to keep it on-site and off-site using what's called fountain erasure coding, where the content is spread across disk devices in multiple locations, and you can actually lose an entire location and still retain access to all of your content. And then finally, the magic word these days, again, as I said earlier, is cloud. And some people want to have private clouds. They want to build their own cloud environment. They've got to say a secondary or 2 other sites where they can distribute content and keep it within their organization. And then there are public clouds, organizations that will allow you to upload your content to their cloud and then charge you an arm and a leg to bring it back if you ever need to. But those options are available out there as well. If you choose the public cloud, then you've got to decide amongst vendors. A number of considerations there: cost, availability to you. Not all of them are available in the entire country yet. Those types of things. So when you're building this data management layer under your workflow, there are a lot of considerations that need to be taken into account. So I build a high-resolution workflow. Again, this is kind of a mirror of what we saw earlier: ingest, transcoding, work in progress, the whole deal, and then finally delivery. But what we found is that when we were a file system only technology, a software only technology with StoreNext, excuse me, doing my Marco Rubio thing there, drinking during my presentation. Few people pick up on it. Okay. In any event, what we were having problems with is that I've got a user that has a StoreNext file system on a SAN. They've built their own metadata controller with their own preferred vendor. They've got their preferred switch vendor, then they've got their preferred tape vendor, they've got their preferred disk vendor. And as new versions of operating systems come out on their metadata controllers, as new firmware comes out on tape devices, etc., we were constantly battling with compatibility issues between the different areas in the storage environment. And about 4.5 years ago, Quantum decided, let's make this a lot more simple. So we built some purpose-built devices, our metadata controllers. We brought out our own line of block storage disk devices. And of course, we've always had our own tape libraries. But by doing that, what we're able to do is deliver an entire end-to-end workflow support system on that data management layer, so that if you upgrade your tape library, say LTO7 comes out early next year, we know that it's going to be supported by the StoreNext software. So by doing that, we've made our lives a lot simpler. It wasn't a selfless thing. We were trying to help. We were trying to help our customers out, happy customers or return customers, but we're also trying to make life more simple on ourselves. And by coming out with these purpose-built devices from end to end, we were able to make a more reliable solution available for our customers. Again, I'm trying not to keep this too salesy, but I do have to mention the things. We bought dinner, by the way. So, got to get a little return
But you
on
can't
that
sell the
investment.
products.
No, I'm not
Just
selling
disappointing.
things. Well, actually, I stole some of these diagrams from a coworker, and they had quantum gear in them, so it's advertising itself. I don't have to point it out too much. Something else that we found, the standard workflow has been you bring in content, you work on it, you back it up every night with your regular backup software, your regular backup scheme like you've always done in IT in your organization forever. I'm going to back up, do incremental backups or differential backups during the week, full backups every week, every 2 weeks or once a month. Problem is that, and Ken mentioned before, things like 4K are here and they're real, and you can't back up 50 terabytes in a weekend. It just doesn't happen anymore. You can buy massive tape libraries from Quantum with 50 drives in them, and we'll back it up over a weekend, but that's not reasonable. So as part of building this workflow, we've also built in data protection schemes to it. It's anything magic that we're doing, but by doing things such as, and that should say archive on ingest, not archive to ingest. As content raw footage comes into, say, an environment prior to being edited and broken out into a project and sent off to make money for your organization, that raw footage is never going to change. So why not remove that from your backup pool, your nightly, weekly, monthly backup pool. Make an archive copy of it as soon as it lands on that device and remove it from your backup environment. That way you've got a copy that's protected on day one. That content's never going to change. It's raw footage. It's not finished product. And then when projects get finished, archive those off immediately and remove those from your backup scenario, your backup scheme. We have the ability to do that. We can set up rules within the StoreNext file system that says anything that lands on this file system after 15 minutes, make a copy of it immediately. Leave it where it is, but make a copy of it. So I've got it protected. I never have to back it up again. That's being done automatically for me. I don't have to worry about it. I have protection for my content. It takes the stress off your backup environment. It gives you a secure copy of your data, and it happens by itself. You don't have to count on somebody doing that every time. You take the human element out of it to a certain degree. The rest of it all stays the same, but by doing that, I've got work in progress. I do my nightly backups. My editors come in, they do hard work all day. They go home at night. I want to protect what they did. So when they come back tomorrow, if something happened to it, it's available to them. But there's large chunks of data, there's 30, 40, 50 terabytes. The cable channel that I have up in the Northeast, we have built their object storage out to 9.998 petabytes currently. You don't back that up, or you don't back up even portions of that. So by changing that part of the workflow, by making an automatic archive copy as soon as content lands in your environment, has to become part of the workflow. It's not really optional anymore. I mentioned private cloud earlier, and the devices on the right where it says Lattice Private Cloud, that's the quantum object storage technology. I've got several customers that are doing that. They're building a private cloud. They're moving the content off to object storage. They've got multiple sites, so they can distribute the data across 3 sites, and if they lose an entire site, they still maintain access to all of their content. It's like making a backup without making a backup, if you will. They just write the content out to Lattice, and it stays available to them. And it stays within their organization. And that's important because some of the hesitation that people have currently about moving to the cloud, they always hear about, is that they're turning their data over to somebody else. It's getting out of the building. It has value to their organization. They don't want to let that become vulnerable to somebody else's lens. They feel more secure if it's under their control. Or they just have an organizational policy that says we don't let our stuff out of the building. So by building this private cloud, they can take advantage of these new storage technologies on the archive tier without violating any corporate policies they might have or making themselves stay up at night worrying that somebody else has control of their livelihoods. The rest of the diagram stays all the same. Basically, on close to the lower right-hand corner, we can still make a copy to tape. If you want to keep that tape copy, make a copy to the private cloud, if you will. The tape copy gives you the option to send that tape off to Iron Mountain so that We are in a part of the country here that is subject to severe weather sometimes. If that's a concern, it allows you to have your private cloud, but also have the security of a copy that's got great separation from the primary copies. This is basically just moving, not a lot has changed here, but I've added a cloud that's not labeled in the lower right-hand corner, letting the content get out of your organization into the public cloud, but everything else stays the same. It gets really busy up there after that, with all the arrows and things, but they actually are pointing at stuff. The key to this, the key reason that I put this up there is that with high resolution, with 4K, you're going to have massive amounts of content. With StoreNext Storage Manager, you can automate the movement of all that data, whether it's going to object storage on site, to a private cloud, if it's going off site to a cloud, if it's going to tape, if it's going to a secondary tier of disk, no matter what your target is for your data protection, your archive, you can build policies that do that automatically. A guy I worked with many years ago said there are the 4 F's of data protection: fire, floods, fools, and felons, and at least this type of automation protects you from the fools. It allows you to have that content protected automatically all the way through your workflow from ingest to delivery to your final customers. And the key to all of that is that everything up there can say quantum on it, or everything except for the metadata controller can have somebody else's brand on it. If you have invested in well-performing, valuable hardware that is doing the job for you, and Quantum walks in and says, we can build this workflow for you. We don't make you throw everything that you have in there out. We can build it on what you have, again, subject to those compatibility issues. But we don't force you to throw your big gear out and bring in Quantum gear. So it can be a hybrid of your stuff and our stuff. It can be all your stuff with the exception of the metadata controller, or it can be all of our stuff. That really makes it easy for us to come in and help you build out your workflow, whether it's a greenfield from scratch environment. I was just doing one of those for AOL last week. They're building a whole new edit suite, and it makes life really easy when we can build it from square one to the last screw going into the rack. But we've got other customers that have workflows that they've been using for years, but they want to take advantage of new technologies. They're having to expand their capacity. They're bringing on more editors. They have to expand their throughput, whatever it might be. But by having a solid workflow like that on purpose-built gear, it makes it easier for us to expand it without having to do forklift upgrades. We can build on what you have. We can modify it to make it work for what you need to get done at the end of the day. And I apologize, this looked a lot bigger when I was looking at it on my laptop on the plane the other day. This is the last thing I'm going to put up there. This is it's for a really big national TV network. They put out an RFP for their next generation of their content delivery system, and it's kind of an example of what we can build for them. Starting over on the left, they have their content that comes in from, I can't say where because you'll know who they are. They're archiving on-site using a quantum tape library, and then they've built a private cloud using our Lattice technology, our object storage technology at 3 different sites, 2 in 2 different places in Virginia and 1 in Lincoln, Nebraska. Their content comes in to Virginia, is distributed. They've got a lot of custom stuff that they've built where I wrote custom GUI down there at the bottom. They're using OpenText as their asset manager. Everything is done through OpenText in their custom GUI, but the content moves through this environment, and their remote sites, they have 172 remote sites, are pulling all of their content off of this Lattice object storage system. That's their distribution network to their 172 local stations. And then at the end, they have our new Quantum Artico NAS device. Basically, it's a way to use StoreNext Storage Manager without having a StoreNext file system on the front of it. So it's just a NAS mount, and they're using that at the remote site so they don't have to build a StoreNext file system at every site. And then they're protecting everything off to the Quantum Q Cloud up at the top there. So we haven't done it yet. We're in the process of revamping their entire content delivery system across the country. And we're doing it with our Lattice object storage as the hub of that. So it's just kind of a real-world example of a workflow from beginning to end. I actually was on the phone with the guy today, and he told me I needed to write arrows from the right side from the remote stations back into the front because they get their content out there. They air it, they make their changes to it, and then they send it back to the big house to be redistributed to all the other stations. But it really goes back to pretty close to that first workflow diagram that I had up there. And it's all quantum from end to end. And the reason that we could do it as efficiently, as quickly, is because it was quantum, and we don't have those compatibility issues. Operating systems on the different devices are set by us. The capacities of those devices, the physical characteristics, RAM, and that type of thing are all set by us. So they have the ability to know that anything that they plug in there is going to work with the rest of the environment. They've kind of built a Lego block environment, if you will. So as they have to expand, they have to make changes. It's just a matter of plugging in more blocks without having to redesign the technology. So are there any questions that anybody has? Yes, sir.
Excellent presentation, thank you. A
Thank
couple
you.
of questions. If you're not using a third-party media asset management, maybe you stated it, but I didn't hear. Does Quantum supply the software? Does it look like another file extension letter to the system? So you can look it up, and does it create a thumbnails? And it's a multi-tiered question. And also, if you go into offline or cold storage, does your system know where it's parked at?
Okay. The answers to those are no, no, and yes. We do not do it in an asset management type thing. We do work with asset managers, our StoreNext technology.
That's why I asked that question. I wasn't sure if you supplied your own workflow software.
No, Storage Manager does integrate with most of the most popular asset management tools out there. So you can quote archive content through your asset manager, and he will actually call StoreNext under the covers to make that data move. The last part of it.
Cold storage,
Cold
does it
storage,
know
yes.
where it's parked at?
Yes, he does track the content wherever it goes. As a matter of fact, you can delete it off. There are a couple different ways you can do it. The content remains in the file system to the end user. The physical location of the data is transparent. They went into volumes, whatever, to see this file today, and then because of a rule that was set up, that content was moved from the primary storage tier off the tape. It's still in the same logical location from the perspective of the end user, even though it's physically moved to another tier. And it can even get to the point where you can delete content from the primary tier, not even leave a stub behind, and still go retrieve it through the StoreNext user interface, whether it's on tape or object storage, wherever it might be. So yes, it does track physical location of data everywhere it goes.
So,
yes, sir.
Block storage, the lattice controller, is that what it's called? That maintains the block storage location and the information? Is that?
Well, the StoreNext file system is the manager, is the traffic cop that keeps track of the location of all the data, wherever it might be, whether it's on the primary RAID storage tier, whether it's on the lattice object storage, or whether it's on tape. That's all managed in the StoreNext file system.
Okay, so, but block storage isn't like file-based, it's a block storage, right?
Yeah,
So
look, and
controller that says this is what I am and here's where I live, right?
yeah.
So if I take that somewhere else, that's not a universal piece anymore, right? I would have to have that lattice controller to reconstruct that block storage.
If you were to just pull this tray of disk out of the rack and take it somewhere else and plug it in, yeah, StoreNext is what is tracking the physical location of that data on that disk, distribution of data across there. It's a SAN.
Yep.
But it's a SAN that also does track the file systems.
But that's how you reconstruct if you have a failure. In the
Yeah, everything in here backs up automatically. Up there where it says work in process, that's a quantum StoreNext metadata controller. It's a 2-node with metadata disk in between appliance in a failover configuration. He's the traffic cop. All the information about the file system is in there. That gets protected along with all the other data so that you can reconstruct that StoreNext metadata controller essentially from those backups as well. Any other questions? Again, thank you very much, Ken. Thank you for inviting Quantum to speak tonight. Doug, thank you for setting this up. And again, January, February, I'm available for golf games, lunches, or presentations. Thank you.
Little round of applause here, please. I know it's difficult. Sometimes you have to hear my voice say, "Oh, we're not selling product." One of the understandings within the SMPTE organization, especially one like this is a technical group, not a sales and marketing environment. However, we do allow the subliminal relationship between the product and between the technology. It's important. Yes, it's true. Steve made the point. Our presenting individuals do help support you in the way of caloric content and absorption. So with that does come some kind of reciprocal. So I appreciate that all the way around. Most of the point of all this, obviously, is to increase your knowledge technically, have you ask the pointed questions from a technical side to make this a little bit to betterment your education and background. So our next presenter, thank you, is, as I mentioned, Phil Bennett. Phil's Vice President of Engineering for Abacus. Phil has the most colorful presentation. I'm sorry, most colorful presentation. Simple presentation. Thank you. Thank you very much. Here's your.
Okay. We'll try and figure out how to work it.
Arrow that way. Send you forward.
Okay. I'd just like to thank SMPTE for inviting us. As Ken mentioned, the last time we gave a SMPTE presentation was a very long time ago. But we use the SMPTE standards every day, the engineering standards. And those SMPTE standards are what keep the manufacturers from coming along and setting their own proprietary standards that won't interoperate, at least at the television level. And so that's really the valuable work that SMPTE has done over the years from a manufacturer viewpoint. So onwards. So Abacus is a very old company. It's been in several incarnations. And obviously I'm an engineer and not a marketing person, so there's very little chance I'm going to sell very much, I think. What I wanted to do was to talk about some of the developments that we see being important in what we call the grubby business of television, which is the real-time video interconnect between devices. So the opposite end of the spectrum to file-based. And obviously file-based is incredibly important moving forward, but there's inherent in television a lot of real-time operations, especially in sports and news. And that's really where the area where we focus our efforts as a small company. 4K is clearly on everybody's minds out there. Ken's been presenting on it. Everybody's talking about it at NAB. Nobody is quite sure where it's going to go. Obviously in the consumer space, most of the devices being sold today already support 4K. And in terms of entertainment imaging, Hollywood as you'd call it, pretty much everything is being shot in 4K. So we're the kind of HD people in the middle. And as I'll talk about, we've got this funny BNC with serial data on it that no other industry even knows what it is. So we started in 1982. Three of us left Ampex, which some of you probably know and some of you probably don't, but was a very old line video equipment company going back to the invention of tape recording. And back when, even when we started, video was still relatively difficult to do, especially digital video. We worked on early generation digital disc recorders, and obviously that's how we kind of moved into the server business in later years. And over the years, what I really want to talk about tonight is the way we connected those devices together. And I think some of you here are probably old enough to remember NTSC analog connectivity. And I just wanted to talk about what had happened between NTSC and now, and what that teaches us about what to do when we get to 4K real-time interconnectivity and what some of the ideas we might use and some of the ideas we probably don't want to repeat are. So what we build these days is a variety of disk-based servers that really focus on the real-time broadcast industry. We get used a lot for video key playout, on-set playout, live instant replay. And we have another product called the Air Cleaner, which we joke is the product that nobody wants to buy because it's an obscenity deletion box. So most people buy it and never ever use it. So just to talk about the mirror and what we need to do moving forward, the mirror's an 8-channel server, has a bunch of different codecs, a lot of different video IOs. We're a small company, so what we try and do is to build what we need to build, and then we source everything we can from the wider computer industry. And you'll see how that influences what we think about 4K as I move ahead here. So we build our own video IO hardware, we build our own codec boards. The software we do ourselves from the device drivers on up. So we're a little bit different to some of the smaller companies in that we do an end-to-end design rather than just hardware or just software. One of the reasons people buy our system is that you can import pretty much anything from a cell phone to an 8K video. And why this is important, let's skip over this one, is we already do 4K in a tiled environment because we can bring in a file and we can tile it across a bunch of 3 gig or 1.5 gig SDI outputs. So the early 4K adoption is using 4 3 gig HDs to split the raster up into 4. So when we bring a file in, we can tile it across an arbitrary number of BNC outputs to make arbitrary resolution displays, whether it's 4K by 2K as we call it, or 8K by 1. And so this is a mirror playback from Jacksonville Jaguars up the street. And again, this is interesting in terms of what's happening with 4K, because this is actually an 8K by 1K playout using tiled playback. And the systems there can actually play video key at that resolution because they want to be able to key in that very high resolution on the boards. But again, this is all using what looks a little bit like Stone Age SDI interconnect technology. And so a short history of how this interconnect technology works is probably interesting here. Most of you already know this, but some people I think have probably missed most of this fun along the way. So when some of the people in the room here started out, I know that it would have been NTSC on a BNC cable, and I believe it was actually it wasn't a SMPTE spec, it was RS-170A, I think. And this was how television was moved around in very large complex plants, and it was just a total pain in the ass, especially in NTSC, because timing, hue, all kinds of things needed to be constantly set. So around, I think, the early 80s, somebody had the bright idea that we'd get rid of all the colors changing all the time and we go to analog component. And that was very similar to what we're starting to do now, which is where we're going from one wire to carry the TV signal to maybe 3 or 4 wires in a tiled environment. And not many TV stations, I think you guys probably know better than I do, went analog component, but some very large post-production facilities did. And it got really very complicated just because of the number of cables. And if one fell out, it was kind of a disaster. So then came composite digital, which was very nice, except it still had the NTSC problems of footprint. And it used very large, thick cables and 25-pin connectors. But still had the resolution. The resolution wasn't any better than NTSC, which had been around since, I'm not sure of the dates, I'm guessing it's the 30s in this country. So that still had the very poor quality. Next came component digital parallel, which again in the post-production sector was hugely important. And everybody could see the picture right away, and it was clearly completely different to what they'd seen on their monitors before when you saw a component picture on a monitor, especially if it was in a TV facility coming out of a camera or to some degree coming out of VTRs, which were still relatively less capable at that time. So moving on to the last 25 years, this is what we've got right now. So what happened in the late 80s, a guy called Takeo Iguchi, who some of you may have met from Sony, went away in a corner over in Atsugi and came up with a chipset that would take the parallel cable and do 270 megabits. And Sony sold that chip to all the other manufacturers. So rather than Sony trying to keep it just to plug their stuff together, that revolutionized digital video interconnects in our industry pretty much overnight. And the chips didn't work that well, but they were good enough. And they're multi-chip, so they had a high failure rate. But there was nothing else in technology that we could borrow from back then to allow us to connect the devices together. And you'll see the point of this long-winded approach to how we got where we are in a minute. And so those chips basically allowed you to send video over what had been NTSC coax. So in terms of the plant, all the coax was in place, and if you were lucky, you could get 100 meters maybe on the early Sony chips. You had to buy a new router, but the routers then were relatively smaller than they are today. So 256 by 256 was still a very big router. So what happened next? And I guess originally Sony had tried to do HD with analog, which some of you may have seen, the old 1125 line analog system. Then they tried to do parallel digital, and this happened, over and over again. They'd show up with a new HD machine, and everybody looked at the pictures and were blown away, but there was no practical way of doing it. So what happened next was HD suddenly became practical, and there needed to be a new interconnect scheme for HD, and everybody was very comfortable with SDI serial BNC cables and the routers that they had. And so they went to 1.5 gigabits, which at the time sounded incredibly fast and was actually quite difficult to measure. And the early 1.5 stuff, some of you again deployed it. You'd plug pieces of equipment together and there'd be zits all over the picture and nobody would quite know why. And that was because nobody really had the test equipment. The chips were developed for really a very, very small market in global terms, which is the TV market. And so we were taking something, trying to produce it in low volume for our real-time HD SDI transports. HD blew everyone away at the consumer level. So as soon as somebody saw an HD image in a bar where there'd been an NTSC set before, I think most of you can remember what happened, and it was like overnight all the broadcasters were really pushed very hard, at least in the US, to go HD. In the rest of the world, it wasn't quite such an immediate push for line standard reasons primarily. From HD, we kind of sort of did a next step to 3 gigabits. 3 gigabits has very limited. Who actually has 3 gigabit HD SDI deployed in their facilities at the moment? Well, that's not very many. So 3 gigabit was going to be for 1080p or for stereo, which 3D TV, which obviously didn't work out very well. And so a lot of the equipment sold has been 3 gigabit capable, but a lot of the early chips had a relatively limited reach, so they were limited to 50 meters. And again, moving forward to 4K, this is another issue that we'll move on to in terms of reach on the chips. So the current SDI parts can pretty much go as far as, this is all about launching the signal down the cable, which is really analog, and picking it up at the other end. And basically the equalizer has to work really hard as the frequency increases. So the length of the cable you can have for 270 megabits is very long. For HD SDI now, depending on who you talk to, it's 150, 200 meters maybe. And for 3 gig, probably 100 meters on a good day, with good quality new cable. So the next problem we've got is moving forward to, just to explain, the 1.5 gig that you guys all have deployed is for 1080i or 720p. The 3 gig was intended for 1080p, that other than a few facilities never really happened. And you know, the cynics on the manufacturer side would say that it was because nobody could tell the difference between a 1080i picture and a 1080p picture. So that's why that didn't really get deployed. So moving forward, we've got to decide how, for real-time interconnects, if 4K really takes off, which a lot of people are betting that it will, maybe not overnight like HD, but it will take off, especially for media, for screen-based, you know, Hollywood film stuff. But presumably it will take off for sports as well, which is where this real-time connectivity becomes important. So how we're going to hook this stuff together is going beyond the 3 gigabit interconnects that we've got right now. So one way that we're already doing and is already deployed, even here at Golf Channel, is Quad HD raster. And you can run that at either 3 gigabits or 1.5 gigabits. And that is a bit like component analog, going back to the old analogy. So that lets you, using the existing plant that you've got, taking more channels, do 4K on a trial basis, maybe broadcast if you wanted to. Certainly lots of people broadcast with component analog with lots of cables. There's another faction, and again, we're a small manufacturer, so we don't spend a lot of time worrying about what's going to settle out as the final standard. There's another camp that rather than doing Quad HD raster, thinks they want to do what they call 4SI, which is 4 sample interleave. And the idea of that is that you interleave the samples together in the raster so that one of the cables falls out. You've at least got a shot of staying on air. And obviously with the Quad HD raster, you wind up with a missing piece of picture. And again, that's another way of doing it for this kind of interim step. What's emerged as probably the current leading contender, depending on who you talk to, for 4K serial digital video is this 12 gigabit standard, which some of you probably have never even heard of, and some of you have probably looked at. And this is basically HD SDI on steroids. And it has the attraction that it still looks like our analog NTSC cable. It's still a BNC cable that you can plug into a BNC socket and you get video on the screen, which, talking to some people tonight, is very attractive because if something goes wrong, you can unplug it from one place and plug it into another place. The problem, as I'll explain, is that it's really fast for coax. The other proposed interconnect standard, which I should just explain a little bit, is using commercial off-the-shelf Ethernet. Right now, I think 10 gig Ethernet has been around since 2004 or something, I think, so it's a very old technology in the IT world. The bad news about 4K is it won't quite fit down a 10 gig Ethernet channel. So you've got two choices, either compress it or use something faster. And there's a camp right now that's saying we should put compression chips on every I/O and do it that way, which will obviously work, and it's used for file-based workflows all the time. It adds a lot of cost, and it also adds a lot of latency as the risk. So to move on, what we do inside the boxes for our little real-time television world where stuff has to be played and go to air right now, is that we have to take video and output it usually into a routing switcher or into a switcher, and that gets played in real time. And obviously in an ideal world, we'd all use custom chips, just like in your cell phone. But the TV industry is just way too small globally, so nobody can do that. Even the big guys are forced to use what's called FPGAs. And these are like programmable pieces of hardware. And these have the serializer, deserializers inside. And that's what sits at the edge of pretty much all your signal processing devices. The router doesn't need to take it down to parallel, but your switches, your servers, everything will have probably a FPGA at the edge that actually takes the parallel data and turns it into serial. And the older generations ran fine at 3 gigs. What's interesting is that the latest generations can screen past even this 12 gig interconnect standard and run at least 30 gigs, excuse me, and maybe even faster in some cases. So what we design inside our equipment is no longer the limiting factor in terms of the interconnect speed. So whether we want to do 12 gig SDI for the next generation or whether we want to do 10 gig for us or any of the other manufacturers is relatively easy. So, as I said, we're a small company, so the problem we've got is that we can't bet on everything at once. So we need to try and pick a winner and focus on that rather than try and design for a bunch of standards that don't move forward. So 12 gig SDI is really nice because it's simple and everybody understands it, and it's just coax and it's the routers we've all got right now on steroids. We have to buy a new router, but the killer problem with 12 gig SDI is that it only goes 50 to 75 meters right now, and it's unlikely to go that much further. So it's okay for post-production islands, but for a facility like this, it's probably not really going to work out so good. And the real killer problem is it's another industry-specific protocol and transport and everything else. And to get the 12 gig even to go 75 meters, everything has to be perfect. So you won't be kinking the coax. You probably won't be using patch bays, which was one of the reasons that we wanted to stick with the BNC infrastructure to begin with, because the loss budget just isn't there. You just can't stick a bunch of barrels on the cable and expect it to work. So the next choice is something called SMPTE 2022, which most of you are probably familiar with, but just a brief explanation. This is another great SMPTE standard that a lot of people in a lot of big companies have spent a lot of time mulling over. And what this allows us to do is to take what was the serial data that we'd sent over our coaxes, packetize that up and send it over an Ethernet cable just like you've got plugged into your computer at home or into your router at home. The way SMPTE 22 works is quite different to the way the internet works, and that's an important distinction. So the way computers talk is usually via TCP for talking backwards and forwards, and it's assured delivery. If the computer at the far end doesn't get it, it tells the other computer to retransmit it. So if there's a lot of link loss, the link rapidly dies in a blizzard of retransmits. For SMPTE 2022, it doesn't work that way. It's much more like Netflix streaming. So if it loses a few packets, you're out of luck. You're not going to get those packets because it doesn't have time or energy, or it's not designed to retransmit them. So SMPTE 2022 uses, it's called forward error correction. It uses a wrapper around it that adds a bit of data rate that lets you construct to reasonable error rates on the video. If the router starts dropping packets that's transmitting that, for a TCP connection like you'd have on when you're talking to the internet, that's not a big deal. But the router for SMPTE 2022 mustn't drop packets. And that's a kind of important distinction, that if you start to overload stuff and lose packets, bad things are going to happen to you. And so the people that are doing this know to deploy lots of reserve in the router and to make sure that all the links are pretty much error-free, which was in some ways the opposite of what the TCP protocol was originally designed for, which is the upper-level protocol. So this SMPTE 2022 is a way of sending video from point A to point B through the internet, but when you launch it, nothing had better get in the way. It has to get to the other end. SMPTE 2022 scales really well. On a 1 gig Ethernet, you can do a lot. On a 10 gig, you can do several HDs. Nobody's frightened of doing 10 gig Ethernet max anymore. It's pretty easy. People do that all the time with FPGAs, and obviously this is a bit different to the NIC cards in your computer that you're familiar with. This, what we do from the FPGA, it's much more a hardware launch of the packets because we need to know when they're going to be launched with pretty low jitter. So you can do it from a computer, CPU and a NIC card, but that's not the best way to do it for, again, our little business of broadcast where we want stuff to arrive in real time. So SMPTE 2022 runs over conventional Ethernet cabling and routers, but you need to be careful. It's not just like hooking up, bringing up a web page. So that's going to be deployed and is being deployed for HD. So that to us seemed like the better bet because that's already the next big thing for people. The problem is, and it's a big problem, that if 4K 60 comes along, uncompressed won't fit. So we need a faster Ethernet standard, and there is one. There's 40 gig Ethernet, and that's been around for a long time, and it exists in data centers. I've never seen a broadcast customer that's ever deployed it. The problem is it's just 4 10 gig Ethernet transports in parallel, so it tends to cost 4 times as much, which obviously isn't. And also it's 4 lasers instead of 1 laser to drive an optical cable, so the reliability is probably not as good either. The other problem with not having any room to grow for 4K 60 is that, as Ken alluded, we've got high frame rate potentially coming along, and not so popular here, but in Europe there's a lot of talk about high dynamic range, where we might use more bits per pixel, because that may look different at the consumer level. And obviously for 4K, one of the issues is that as delivered to the consumer right now, it doesn't really look any different to HD, especially if you're more than 3 or 4 screen heights away. So having a 4K standard that you're already trying to compress to even get it down the links you were designing it for didn't seem like such a great idea to us. The nice thing about using 10 gig Ethernet is that, pretty much not quite at the computer store level, but certainly at the regional distributor level, you can buy 10 gigabit pretty much anything you want. It's an industry standard. It's nothing to do with television. You just go there and buy what you want. So what we've been looking at, and we're in Silicon Valley, so everybody, the word disruptive there is used a lot. Last year, out of nowhere, came a 25 gigabit Ethernet standard, which IEEE, who's they're kind of, you guys probably know who they are, but they're kind of the SMPTE of the IT world, and they have an Ethernet consortium, I think, that basically sets the way Ethernet's going to grow. And they'd already come up with a 100 gigabit Ethernet standard that they were going to use for the next tier data centers, which was actually 25 gigabit times 4. And what happened was that Facebook, of all people, said, this 10 gig's not fast enough for us, and by the way, we're not having any of that 40 gigabit stuff. And by the way, we're building our own switches. We're not going to use any of those Cisco ones or anybody else's because we can. And so they basically, and a few other companies, gave an ultimatum that said, you need to standardize 25 gig E right now, otherwise we're going to go do our own thing and leave the IEEE behind. And that was obviously pretty strong leverage, which in the main we don't have in the broadcast industry. So a lot of vendors now are off doing 25 gig E, and that seemed like the logical way for us to look at if we want to do 4K as a transport. And I don't know what other manufacturers are doing, but I suspect they're looking hard at it as well, and I'll show you some reasons why that might be. So 25 gig Ethernet looks just the same as 10 gig Ethernet now. There were some early implementations for 100 gig that had huge bit connectors, and they were, looked like something out of a telco building. Now, and these are available, they look just like Ethernet, 10 gig Ethernet SFPs. It can carry one 4K uncompressed, possibly 2, and certainly 1 HDR 4K. And one thing that's worth talking about in terms of the way we handle switching video, right now, I'm sure at Golf Channel and at most other customers, they have one huge switch, a huge routing switcher that everything goes into and everything comes out of. And that's not really the way you build data centers these days. Data centers are built using tiered switches, and they have backbones between them because it's too big to have one big switch, and it also gets incredibly expensive. So they have what they call them leaf switches, but they're top of the rack switches. So they'll have a very high performance switch that sits in the top of the rack that takes all the traffic and spits it out. And what's nice about the way the 25 gig has evolved is that all the switches have 100 gig ports as well. In fact, that is the port. I'll show you an example of one in a minute. It's not quite here yet, but the first switches are shipping in September. So how do we talk to a 25 gigabit Ethernet switch? People are already doing this. It all sounds very esoteric to us in our 1.5 gig SDI world. State of the art with a current 20 nanometer FPGA that's shipping now, and again, the FPGA is the programmable logic that we use to build our products. There's evaluation boards that have 4 QSFP28s, and each of those is 100 gigabit. It's 4 25 gigabit links. So that's 400 gigabits in each direction. So it's 16 25 gigabit Ethernet. So up to 32 4K streams just off a single PCI card. This also has Gen 3 PCI on it, which is the 8 gigabit PCI Express interface. And so this is what it looks like. So this is a regular PCI Express board that you've all seen. This is what one of the 100 gig NICs looks like. And so each of these cables can carry 4 25 gigabit Ethernet streams. And this is what the end of one of the cables look like. It looks just like a 10 gigabit SFP. And so that's running today, which is interesting. And again, it's very different to what we do in broadcast. The initial applications for this seem to be military radar and stuff like that. But the 25, that's where the 100 gig is going. The 25 gig, the initial stuff is all going to Facebook and Google, as far as I can tell. So it's going to be a very large market for that. So how to switch the 25 gig E? Again, Silicon Valley is all about being disruptive, which is where we come from. And obviously, big traditional companies tend to go to the big traditional vendors, like Cisco or Juniper or Arista. There's a whole bunch of different switch vendors. But what's happened in the very large data centers is that they've decided to cut it, because they're very large customers, they've cut out the middle tier people, which would be the Dells in this case, maybe the Ciscos. And they've come up with an alliance called the Open Compute Platform that actually designs its own hardware. And this has some interesting implications, not only for price, but also for what's going on in the TV industry. So that's what a top of the rack switch is. Typically, the early implementations of this use a single chip. It has 3200 gigabit Ethernet ports. So it'll do 128 25 gigs. And remember, because this is the way that our SMPTE 22 works, it's not really a bidirectional protocol. So this, in some senses, is a 128 by 128 router for $20,000. And it's not quite fair because you've got to plug the cables in. It might need optical cables and stuff. But this is going to be sold in October for $20,000 initial. And so this is from a company that I'm sure you've all heard of, because the chips are probably in your cell phone, called Broadcom. And so this is a demonstration of what they call their Tomahawk chip, which is a single chip that you can see right there in the middle with 128 bidirectional 25 gigabit Ethernet ports plugged into it. And this is an example of why we're not feeling very comfortable about 12 gigabit SDI on BNC moving forward, because the rest of the computer industry has kind of moved away from what we do for traditional interconnects. But we still need to be pretty careful because most of what goes on in the computer industry is TCP. So there can be some packet losses in the switch. The other problem we've got, especially for real time, is latency. So these newer generation switches are essentially non-blocking. They're not going to drop packets even if you load up all the ports. The other interesting thing, which comes out of a completely different industry to ours, is that the latency through these switches is now very low. So to get from one port to another port in this switch is 400 nanoseconds, which even if you cascade a bunch of switches, we think is going to be pretty decent for real-time television operations. The reason they tune the latency so low in these switches is for the high-frequency trading market. It's Wall Street, which is another huge market for these switches, because they want to be able to execute shared trades ahead of somebody else. So these switch latencies are really low, and that's who beat Broadcom up to really get those latencies down. And so I don't know what geometry this chip is. I'm guessing it's a 20 nanometer custom ASIC. So, you know, it probably cost them tens of millions. And I know they're having to spin it, so that's probably another 10 million right there for the mask set. But you can kind of tell what's going to happen when this chip starts to come down in price. So the initial version of this switch is 20,000 with a single chip. There's another vendor called Cavium coming out with a similar chip. So we think that this high-speed Ethernet connectivity, which is still, even at the 10 gigabit level, is quite expensive, is going to get cheap very quickly. So one other interesting thing about these switches, just make sure I didn't miss anything, is that they don't come with an operating system. So it's like buying a Cisco switch and there's no operating system included. So they're called white box products. And the reason is that a lot of people want to tune these boxes for application-specific markets. So if you think about the way Linux came in at just the right time for the internet, there's several vendors out there that sell in the main open source operating systems that you can load on these switches. So in the US, there's a company called Pico 8 that makes a management system, operating system for this switch that lets you control this down at the fine grain level. So in terms of the special source we need for our video stuff, the fact that it's an open source platform and not a closed architecture switch, we think will make inroads into the broadcast industry quite quickly, especially because this is just using the same silicon chip as everybody else is using from Wall Street to Facebook. So that's what we think we want to do in terms of 4K connectivity. And you can see we've got the pieces there. We're not really sure if the market's there yet, but that's what we think the interface choice will be for us. It's 25 gig E rather than 100, rather than 10 gig compressed or 12 gig serial. For now, Quad HD in the interim works great and there's no risk attached to it. So again, a somewhat maybe off the TV topic talk, but very relevant to how we're going to connect stuff together in the future, at least in our little real-time television world.
While we have a little bit of time left, I'm actually going to take you through only a few slides, but something that's totally relevant and ties into what was said here about 4K. So I won't bore you with the entire presentation, but there's some points here that I think are very important and will probably excite the group a little bit.
Just give me a minute. Sorry.
Okay, thank you. So what I want to talk a little bit about is this whole HDTV mainstream production tool set. What's it all about? Well, we got dynamic range of TVs that we're talking about, the color space, IP-based cabling that we just had a little bit of a review on, viewpoint, frame rate, resolution. All of this is some of the issues that we're talking about. What does this relate to? 4K cinema, UHD, which is 3.8, versus the 7.6, which is the 8K, which we'll talk about in a minute. Color space, the 3D stereo, virtual reality, blah, 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 all coming around. So what is 4K? So on the SDTV side, your standard def, 720 by 480. On the HDTV side, 1920 by 1080, otherwise known as your traditional 1080. 2K cinema, 2048 by 1080. And this is all the relationship of what is 4K or Ultra HD, Quad Full HD, which is prevalent today in Japan, 8,294,200 pixels. And soon to come, 4K, 2K cinema, right around the corner here. Both of these elements are called 4K. QFHD for broadcasting, a true 4K signal versus the UHD that you see at your Best Buy. Different approach. I'm going to try to move it along just a little bit. So we deal with this issue all the time here at Gulf Channel in our quasi 4K cinema room. So what is it? So you got a 4K picture up there in the corner. You're not going to be able to deliver this to anybody that's streaming, I'm sorry. Unprepared. As you can see right there, 3840, which is your 4K by 2160. What is that? UHD, which is 4 chords of a 1080 signal. What does it look like in actuality? Well, here's your 4K image with resolution. There's your 1920 by 1080 HD picture in resolution. That's what you're seeing the difference in when you're looking at a 4K monitor, quasi at Best Buy, versus your HD monitor at home. One of the big benefits of 4K today on TV is that you don't have to sit 25 feet away from a 65-inch TV to see the clarity. You can actually sit within 3 foot, 4 foot viewing space to have the resolution of that picture there. Very, very important. If you're too close to a 1080 signal, you see jagged pixels, you see the outlines, you see all of this screen door effect versus a 4K picture. It's a wider picture, much more immersive in viewing, fills up a greater space. You see today when you go into some of these stores, there's a curved 4K display available. They want you to now be immersed into the picture, sort of like poltergeist. So let me give you a little bit of the roadmap. This is the industry's roadmap, which will help you a little bit. In 2014 to 2015, you have full HD and 4K. It's here today. Trust me, it's here today. 2015 to 16 is the 4K Ultra HD TV, and HD as we know it is going to start to take a back seat. But more importantly, in 2020, projected in the industry, is an 8K signal. Now you're saying, well, come on, 8K signal. In Japan, that is becoming our 4K. For real. I know people say, nah, yeah, for real. So all this 4K technology, what does it all mean? Well, we have a lot of elements here. We have exhibition, which are servers themselves. We have 4K digital cinema. And one of the benefits of an 8K digital cinema is a gorgeous picture to be able to present and project 8K digital. 4K home projectors, I don't have one, darn it. 4K Ultra televisions at home, 4K production cameras for acquisition, and et cetera, et cetera, et cetera. So the 4K world is already built. Not only do we have monitors for sale in a professional world or for home viewing, but all the production elements to go around it, the exhibition elements, the distribution, servers, all of this are all here today. In the home, we have, and that's the Comcast Xfinity X1 box I was talking to some of you about at dinner today. You have 4K boards on computers. You have your iPhones, your 6S soon to be 4K, your 6, it's 4K. You have, obviously, gaming devices, 4K laptops. So it's, again, it's real. So what do we got here? One of the big problems is bandwidth, and it's all about bit rate, and I know we talk about it all the time, and certainly Phil mentioned bit rate to a great degree, but in a 1080i high definition signal, that's your bit rate. But what about 4K? That's what you need for 4K for bandwidth. That's the big problem. That's the problem today, it's the problem tomorrow. So what are those bandwidth connection requirements? Kind of give you a review. So a standard broadcast connection speed at home is about 0.5 megabit per second. The recommended bandwidth rate is 1.5. So 1.5 megabits, I got a broadband connection signal. At 3 meg, you got an SD signal. At 5 meg, you got an HD signal. So what's the next thing we need for Ultra HD? 25 megabits per second in order to deliver a streaming 4K signal to your home television. Huge bandwidth, back up to what we talked about a minute ago, huge bandwidth. Most people today are ordering from their cable operator 6 meg, 8 meg, 10 meg, maybe 12 meg. Now we're talking about 25 megabits to get that signal there. Difficult. Other problems. No one's really come up with a 4K distribution standard for the home yet. There's no standard. The size of a 4K movie depends upon quite a number of variables, including the standard, the bit rate, and the type of compression being used. Obviously, compression is unavoidable. So many different algorithms out there. But people keep saying, don't worry, there's going to be better compression. At what point does that no longer become a better compression algorithm? It becomes bandwidth. I don't care however you look at it. Can't put 6 quarts in a 4-quart jar. You can compress the heck out of it, but there becomes a point that it no longer will accept it. So the difference between good quality video and poor quality video is the result of compression algorithms. If any of you were in this industry back 20 years ago and you looked at streaming on your web and you saw that image, you said, oh my God, I'll never be able to watch that. Look at where that has changed. So many viewers today have even actually given up their standard methods of delivery in order to have a web-based delivery so they can watch their entertainment value. So what are the bit rate requirements for production? Well, uncompressed video bit rate on 4K UHD is 12 gigabytes a second, which is what Phil had mentioned earlier.
Gigabits.
Gigabits, I'm sorry. Yes, which is what Phil talked about a minute ago. So as I mentioned, uncompressed 720 and 1080, 1.5, full 3. There's already what is known as a bandwidth crunch with some HD TV service providers. Some of you people have cable that you probably go home and you say, oh my God, this is terrible. Some cable operators keep compressing to the point where signal is no longer really, really exciting anymore because they just want to deliver more in the same pipe they have. So delivering 4K UHD TV services is going to be very much problematic. So I'm going to skip through a couple of these for a minute, but as an example, 100% of a 4K image would be that relationship. 200% or a cutout of that 4K image to see a replay. That's one of the advantages of a 4K signal, is that signal right there. Still going to look like a 1080 signal. 200% of 4K is that kind of resolution. And I'll go back to that for a second, you'll see that. That's 100%, and that's 200%. That's a 400% image of 4K, so you could cut that out. See the laces on that ball? You see it deflated a little bit? It was the Matrix. That's my team, by the way. Thank you. No clapping, your names. That's 400% from the 4K. That's that 400% cutout, now full screen. Pretty impressive, and that's what you need this technology to drive for. That's an 800% image. There you go.
Here's the needle.
There's a needle. That's what an 800% image looks like from HD. So let me just go back, see the difference. That's why the 4K is going to be very impressive for sports production. This is going to take a lot of time, so I'm going to blow through some of this. But 4K stitching, big in sports. 2 cameras side by side. We get to the end here. So the infrastructure to support 4K workflows and 4K content is evolving. TV manufacturers creating relationships with content providers like Comcast, Charter, Time Warner, Netflix, Amazon, et cetera, embedding decoders for HEVC and XAVC in VP9 and adopting HDMI 2.0, all in anticipation of a broader range of 4K content next year. It's not expected nor is it necessary to upgrade or replace an entire operational environment when making the move to 4K. It's practical, however, to pursue 4K workflows in stages. To lift one plant that's 1080p or 1080i to 4K is millions of dollars. Millions, trust me. I budgeted it out several times this year. 4K presents the greatest opportunity at the creative level, but also the greatest and considerable challenges. So as post-production and broadcast facilities acquire 4K footage, they'll need a storage infrastructure in order to allow them to work with this newly acquired footage to keep up with the demand for more 4K content. You can't put this on an LPO 3, 4, 5, et cetera, et cetera. You need other methods of archiving. Optical disc. Only because we favor that. Magnetic disc. Maybe cloud-based services if you're willing to take a chance. Sorry. That's an opinion. The opinions expressed by Ken Botello are not those of...
The SMPTE organization?
Yeah, that's right, not SMPTE. We've had our own cloud-based successes and otherwise. So that's another subject. That's not covering all manufacturers. That's just covering limited experience. So 4K is here to stay. 8K and 16K on the horizon. I will be dead when 16K is here. But it will say on my gravestone, he mentioned 16K, July 30th, 2015. This is inevitable. It's an inevitable progression. As you, as a consumer, me as a consumer, we crave for better resolution, more vibrant and exciting entertainment medium, surpassing the quality of high-definition content. As an example, my children grew up not watching VHS tape. You show them VHS tape now, they go, oh, Dad, that is disgusting. When I grew up, my wedding's on there. Yeah, it's nice. So that's what we do. We're going to crave for this development if we're not doing it now and currently. We want to surpass the quality of high-definition content regardless of the consumption, channel, or device. I appreciate that. I just wanted to tie this and wrap this into what was being done to let you know that what obviously has been discussed by Steve in storage mechanisms, in workflows, what was discussed by Phil in the sense of technology, and obviously all that's being manufactured today, all is going to relate to you as a consumer that wants to see a clearer, more resolute, more defined, more high density, more higher dynamic range picture. Simple. So with that, I want to thank you all for attending. If you did not let Mike scan your ticket, we all good, Mike? Mike's listening to one of the local radio stations. If he has not scanned that, please let him do that before you leave, because it does account for your appearance here, and I get SNH green stamp. Thank you very much for being here this evening.